Hello friends, how are you? In this video lecture of thermodynamics, today we will see second law of thermodynamics and why there is a need of second law of thermodynamics. So we have to find out limitations of first law of thermodynamics. So to understand this, watch this video till the end. अगर आपको पसंद आता है तो like it, comment it, share it and subscribe it. You know what is the first law of thermodynamics? We have seen about this. Energy can neither be created nor be destroyed, but it can be converted from one form to another form. ये स्टेटमेंट नंबर 1 है, यानी एनर्जी प्रोड्यूस नहीं की जाती और उसको डिस्ट्रॉय भी नहीं किया जा सकता, बट कन्वर्जन इज पॉसिबल, लाइक पोटेंशियल एनर्जी इनटू काइनेटिक एनर्जी, इलेक्ट्रिकल एनर्जी इनटू लाइट एनर्जी, light energy into electrical energy, and only conversions are possible, but it is not possible to create certain amount of energy, or it is not possible to destroy the energy. Statement number 1. Statement number 2, total energy of the universe remains constant. You know what is the universe? Universe यानी system plus surrounding. A universe है, and a system, boundary and a surrounding. So total energy of the universe remains constant. We can say total energy of the isolated system remains constant. This is about first law of thermodynamics. Now what are limitations of this? In first law of thermodynamics, it is not given, there is no information about direction of flow of energy. There is no information about direction of flow of energy. Second limitation, there is no information about spontaneity, whether process is spontaneous, whether system is spontaneous or non-spontaneous. We'll see later on what is spontaneity, which process is said to be spontaneous process. And third, there is incomplete information, that is incomplete information about transfer of heat into work. Whether total heat is converted into work or not, or partial amount of heat is converted into work, it is not given. And there are main 3 limitations. Number 1, direction of flow of energy, that is the direction of flow of heat, and whether from hot end to cold end or cold end to hot end. Second, whether process is spontaneous or non-spontaneous. Now, which process is said to be spontaneous process? When external influence is not required to start the process, and when external work is not required to start the process, that process is said to be what? Spontaneous process. That is example of this flow of water from high altitude to low altitude. A spontaneity, a spontaneous process. External force is not required for this flow of water. What I said, flow of water from high altitude to low altitude. This is not possible, that is from low altitude to high altitude. So this is not explained in first law of thermodynamics. And third, incomplete transfer of heat into the work. And how much amount of heat is converted into work, it is not given. So these 3 are the limitations of what first law of thermodynamics. That is why there is the origin of second law of thermodynamics. So what are the statements of second law of thermodynamics? Statement number 1 for second law of thermodynamics, that statement is said to be what? A Kelvin-Planck statement. It is not possible to construct such engine whose efficiency is 100%. It is not possible. It is not possible to construct such engine whose efficiency is 100%. Yani, it is not possible for any system to operate in cyclic process. In first law of thermodynamics, we have seen what is first law of the mathematical deduction of first law of thermodynamics. Delta U is equal to what? Q plus W. This is the first law of thermodynamics. In a cyclic process, delta E equal to 0, that is delta U equal to 0, यानी change in internal energy equal to 0, यानी in a cyclic process, delta U equal to 0, and a change in internal energy equal to 0. Why? Because internal energy is the state function. यानी suppose ये initial state है और ये final state है, यानी system changes from A to B and B to A, and internal energy is state function, यानी internal energy depends on only initial state and final state. So change in internal energy equal to 0, and this equation will be what? 0 is equal to Q plus W. Therefore Q is equal to what? Minus W. And whatever heat is absorbed by the system is totally converted into the work. But this is not possible. And according to Kelvin and Planck, it is not possible to construct such engine whose efficiency is 100%. Statement number 1. Statement number 2. Clausius statement. Clausius statement gives information about what? Direction of flow of heat. It gives information about direction of flow of heat. That is the flow of heat from hot end to cold end. So flow of heat from hot end to cold end. And in a spontaneous process, flow of heat from hot end to cold end, and a flow of heat from hot reservoir to cold reservoir, reverse is not possible. Reverse में क्या होगा? अगर if it is reversible, so flow of heat from cold end to hot end, this is possible in refrigerator. For this we have to supply electricity. Freeze में क्या होता है? Flow of heat from cold end to what? Hot end. After supplying electricity, without this is not possible. Yani unidirectional flow of heat. So in spontaneous process, there is a unidirectional flow of heat, that is hot end to cold end. A statement number 2. Statement number 1, Kelvin-Planck statement. It is not possible to construct such engine whose efficiency is 100%. And it is not possible for any system to work in a cyclic process. What happens in cyclic process? In a cyclic process, delta U 0 होता है, and a change in internal energy 0 होती है. क्यों? Because internal energy is the state function. It depends on only initial and final state. So it's 0 है. So 0 equal to what? Q plus W. And Q equal to minus W. And whatever heat is absorbed by the system, जो कुछ भी heat absorb की है system ने, so total heat converted into work. लेकिन ये possible नहीं है. अगर ऐसा possible है तो 100% efficiency हो जाएगी. लेकिन this is not possible to construct such engine whose efficiency is 100%. स्टेटमेंट नंबर 1 है. स्टेटमेंट नंबर 2 क्या है? Clausius स्टेटमेंट है. एक इंफॉर्मेशन देता है, that is the flow of heat from hot end to what? Cold end. Unidirectional flow. ये spontaneous है. Statement number 3, this is about entropy. This is about entropy. First, we must know what is entropy. Remember, entropy is the measure of randomness or a disorder of particles. और random particles का randomness है, disorder है. So, as the distance between two particles increases, entropy also increases, and vice versa. अगर दो particles का distance कम होता है, तो उसकी entropy कम होती है. So, in spontaneous process, entropy of the system and the surrounding increases. So what is entropy? Entropy is the measure of randomness or disorder of particles. See here. You can take ice. Suppose this is ice. ये ice है. So in ice, your distance between particles is less. Melting of an ice, जब ice melt होता है तो randomness आ जाता है and distance increased. ये liquid water है, इसका वेपोराइजेशन होता है तो randomness और बढ़ता है. It is like this. यानी एंट्रोपी इंक्रीज्ड. ये स्पॉन्टेनियस प्रोसेस है. मेल्टिंग ऑफ एन आइस स्पॉन्टेनियस प्रोसेस है. वेपोराइजेशन ऑफ वाटर स्पॉन्टेनियस प्रोसेस है. सो इन स्पॉन्टेनियस प्रोसेस एंट्रोपी ऑफ द सिस्टम एंड सराउंडिंग इंक्रीजेस. यानी चेंज इन एंट्रोपी डेल्टा एस इट इज ग्रेटर देन और इक्वल टू 0. यानी इन स्पॉन्टेनियस प्रोसेस एंट्रोपी ऑफ द सिस्टम and surrounding increases. So these three are the statements of second law of thermodynamics. Once again, what is statement number 1? Kelvin-Planck statement. This gives information about what? Efficiency of engine. And in this world, there is no any engine whose efficiency is 100%. And any system can't work like a cyclic process. अगर साइक्लिक प्रोसेस है तो डेल्टा यू 0 होगा, यानी टोटल हीट किस में कन्वर्ट होगी? वर्क में कन्वर्ट होगी. दिस इज नॉट पॉसिबल. यानी इट इज नॉट पॉसिबल टू कंस्ट्रक्ट इंजिन व्हिच एफिशिएंसी इज 100%. सेकंड स्टेटमेंट अबाउट क्लॉजियस स्टेटमेंट. ये सेकंड स्टेटमेंट है. दिस गिव्स इंफॉर्मेशन अबाउट डायरेक्शन ऑफ फ्लो ऑफ हीट. दिस इज यूनिडायरेक्शनल फ्लो ऑफ हीट. इन स्पॉन्टेनियस प्रोसेस देयर इज अ यूनिडायरेक्शनल फ्लो ऑफ हीट फ्रॉम हॉट एंड टू व्हाट? कोल्ड एंड. एंड थर्ड, in terms of entropy, in entropy what happens? In spontaneous process, entropy of the system and the surrounding increases. And a change in entropy, it is greater than 0. So this is second law of thermodynamics. We have seen about entropy. Entropy is the measure of randomness or disorder of the particles. Melting of an ice. In ice, distance between two water molecules less. And entropy is less. After melting, it converts into liquid water. So here there is a randomness and a distance between two particles increased. After vaporization of same water, again randomness increased and again distance between these particles increased, isn't it? So entropy increased. So S is the symbol of entropy. So what is the equation for that? Delta S. Delta S is equal to Q reversible upon temperature. And a change in entropy is the ratio of what? Reversible heat to the temperature, absolute temperature. This is the equation for what? Change in entropy. And this is about second law of thermodynamics. If any doubt, you comment your doubt in comment box. Definitely I will get back to you. Thank you.